Here, compliance stops being abstract. In this module, we turn regulations, business needs, and architecture constraints into a practical control matrix for wallet-based digital onboarding and KYC. Each requirement will connect to controls, design evidence, and audit readiness. We have moved from the policy intent of eIDAS 2.0 through wallet ecosystem roles into a concrete onboarding and KYC scenario. We also mapped the key privacy, audit, and AML obligations. Now the control matrix turns that learning into design input for the reference architecture ahead. A compliance to control matrix is the translation layer between obligations and implementation. Regulations may require privacy, KYC, auditability, and trust, but architects need those expectations expressed as concrete controls. The matrix defines who owns each control, where it is implemented, how it is tested, and what evidence proves it works. That gives architecture, engineering, security, operations, compliance, and audit teams a shared map. At its simplest, the control matrix connects requirements, architecture, ownership, and evidence. Each row should answer 4 questions. What requirement are we satisfying? Where does it live in the system? Who is accountable? And how will we prove it works? Captured together, those answers make the matrix more than documentation. It becomes a governance tool for implementation tracking, risk review, and audit-ready traceability. The onboarding design can be tested through 4 control lenses. Privacy controls check whether we collect only what we need, with clear consent and purpose. Identity trust controls confirm whether the credential, issuer, status, and assurance level can be relied on. Governance controls show whether actions can be proven, evidence is retained properly, and authority is restricted. Operational controls confirm the process keeps working through monitoring, incidents, testing, and review. Consent is not a one-time checkbox. Each wallet attribute request should be tied to a specific onboarding or KYC purpose with the relying party, timestamp, requested attributes, and notice version recorded. If the purpose changes, the data cannot be reused unless another legal basis applies or fresh consent is collected. Strong evidence matters too. Keep proof of what the customer saw, what was requested, and what they accepted or declined. Each attribute should earn its place in the journey. If a KYC decision only needs proof that someone is over 18, do not ask for a full birth date. If eligibility can be expressed as a qualified status, avoid collecting underlying documents. With an EUDI wallet, selective disclosure lets the user share specific verified claims. Store only what is needed for audit or disputes, then apply purpose-based masking and retention. Credential validation turns a wallet presentation into evidence the relying party can trust. Start by confirming the signature, integrity, and any binding to the holder or presentation. Then check dates, issuer status, schema, format, and the required assurance level. Finally, compare the returned attributes with the original request and policy rules. Every pass or failure should be recorded with the time, policy version, and reason, so onboarding decisions are defensible and auditable. After cryptographic validation, the verifier still has 2 trust questions to answer. Who issued this credential, and is it still valid? Issuer identity should be checked against approved trust lists, registries, metadata, or configured trust anchors. Credential status must then be checked for revocation, suspension, or lifecycle changes. The policy used for that decision should be versioned and consistent, with the source, timestamp, response, and final decision captured as evidence. Every onboarding decision should leave a defensible trail. What was requested, what the user consented to, what was validated, and why a KYC outcome was approved or escalated. But not all evidence has the same weight. Operational logs support troubleshooting, while regulated KYC records need stronger integrity controls, restricted access, and defined retention. The goal is balance. Preserve enough proof for audits and disputes, without keeping personal data longer than AML, GDPR, and business risk require. Access control begins with least privilege. KYC analysts review cases, support teams help customers, auditors inspect evidence, and engineers administer systems, but no single role should control the whole process. Sensitive actions, such as policy changes or production access, require strong authentication, privileged access controls, and approvals. Access to identity data, decisions, and audit evidence should be logged, monitored, and reviewed regularly for misuse. Deployment is not the finish line for compliance controls. Once controls are live, telemetry must show whether they still work. Monitor failed credential checks, trust errors, consent failures, unusual onboarding behavior, and evidence access attempts. Also track control health, including log ingestion, evidence completeness, and policy evaluation results. Alerts handle high-risk exceptions quickly, while dashboards and periodic testing provide proof that controls remain effective over time. Traceability turns requirements into proof. Each regulatory business or risk requirement gets a unique ID, then maps to a control objective, a control category, the system component that implements it, and the owner who verifies it. Source documents, such as GDPR analysis, AML, KYC policy, risk assessments, and business requirements, stay linked throughout. If a high-risk requirement cannot be tied to a testable control and evidence artifact, it is an audit gap. An architecture decision record turns a compliance-sensitive choice into durable evidence. For each major decision, capture the context, the options considered, the decision made, and the compliance rationale behind it. This is especially important for choices such as storing presentation evidence, using derived claims, or outsourcing verifier functions. Link each ADR to specific controls and matrix rows. Then revisit it when regulations, trust frameworks, vendors, or risk assumptions change. The key takeaway is that compliance becomes useful when it is translated into controls that architects can build, verify, and audit. A strong matrix connects each requirement to an owner, a system component, a validation method, and evidence. That traceability turns privacy, KYC, trust, access, and operations into intentional design choices. From here, those controls become the input for the target architecture and the end-to-end onboarding flows in Module 4.